Without further ado, let's get to our next presenter. And he is really the man who has been solely responsible for bringing all of this and all of us together today. He is the co-founder of AeroLab. And its current CEO. Started out in the oil and the gas business, but decided to pursue his passion in the sport of cycling. And that brings us today. And I'd like to hand things over again to the co-founder and the CEO of AeroLab Tech, Kelly Zwarych. Over to you, Kelly.
Yeah, a little bit of background about me is I was involved in the tech sector in the oil and gas industry, and just a passionate cyclist involved in triathlon and so forth at a high level, and just decided to move towards that. So I had the technology engineering background, working with product development, and kind of grew from there. Met Chris Morton. We had been doing some projects at the university, met Chris Morton, and the relationship just budded from there. So with my discussion today, really what I want to focus on is future innovation of real-world aerodynamics. So the way I'm viewing a lot of this is and I think Bert did it well, is when he was dealing with heart rate training, how the power meter started to change the equation, how it brought a pure number to the testing, to the development of the athlete and the performance. So that's, if I were to go back a little bit, it's about the advent of how that power meter evolved and so forth, and how the information, and as the product got introduced at a high level to people like the audience right now, how they started using the data and developing it. Because when it first came out, it was strictly power, and then we started to learn a lot about different ways to interpret and analyze the data. So a little bit of a backstory here. So if you are not aware, AeroLab, even though we are passionate about cycling, the application in its long-term vision applies to a lot of areas. We've worked with applications for long-range military coastal surveillance drones, the experimental aircraft. We've done a lot of studies where this can apply to aviation and so forth. Wind turbines. This is another area where the technology from its early infancy stage has great potential. Not only can be a part of optimizing the best locations, but it can actually add to the longevity and so forth of renewable resources within implementing our technology to expand on that. And then areas like autonomous truck transport. As we know, it's a large greenhouse gas emitter. And are there ways to use the real world technology in order to increase the stability, safety, and again, the long range of the technology? So that's a little bit of a backstory on case studies we've done, some pilot projects and so forth from that standpoint. A little bit of understanding of Chris and our principal visions of the company and the technology. So one of the things that we wanted to do when we were developing the technology, we wanted to make sure that the product lineup had potential for growth. So it wasn't just a one-off product. And as I go through this presentation, you're going to see that there's a lot of areas where people in their area of expertise, as innovators and leaders, will start to look at the technology and see if it can be implemented in different ways. We set out to make sure that this met the highest engineering standards and lab standards, so it could be used as an actual tool. And this has to stem from the engineering backgrounds and the academic background of Chris that made sure that we were focused at that level for manufacturers, new innovators, technology, and new product development. When we were developing this, I wanted to focus on assuming nothing. So that we brought in all of the key factors here. So whether that was CRR, yaw, wind direction, temperature, all of the variables. And this will also be an ongoing philosophy as we develop other new technologies that work within that realm. And then we wanted to capture the real world environmental impact, which is obviously the end goal. So getting all those data points and then making sure we're capturing that information on its impact. So we wanted to, it's to increase the value of future designs and products as they develop. So I'm in my next slide, really what I'm going to start getting into is a little bit of the fact that there's a compromise that's made in design. Chris had touched on this, is that there has to be a compromise when developing things within the wind tunnel. So that we have to take in consideration. And he also touched on the fact that no one-off product is perfect for all athletes, whether it's helmets, wheels, and so forth. And that's why we see so many products. And it's exceptionally difficult with performance sports where the athlete's body dynamics are always changing. When you work in traditional aerodynamics in regards to automotive and so forth, it's not a variable bluff body. So traditionally, the engineering process would go with the CFD design as discussed, and then the concepts and so forth would be taken into the wind tunnel. Those ideas would be validated and or need to come back to CFD. So this is a traditional method of development within CFD to wind tunnel to product development, where it's eventually manufactured and brought out into the marketplace. What I really want to show in this scenario is that AeroLab's technology and all real-world development in this area, its intent is not to misplace or displace CFD or wind tunnel, but to actually bring in another component to increase the knowledge in it. So in this next slide, what you can see here is now with bringing in real-world aerodynamic testing capabilities, you can now take an existing product. If there's an intent for a manufacturer to make a better product and they're planning in the next 2-3 years, they can now use the same principles that they used from CFD to wind tunnel, where say they confirmed 60 or 70% of what they anticipated, but then they go back. Here, what you can do now is if you have an existing product, you can test it with the real world technology and then bring it back around into your CFD modeling when you build your next iteration. So I firmly believe that there's going to be a real advent of new product development over the next 4, 5, 8 years that are going to involve real-world aerodynamics in a whole slew of different products. But again, we're talking about cycling, so there's an opportunity with where companies maybe traditionally weren't using wind tunnel because, for example, a shoe manufacturer and so forth within the sports cycling, because of the dynamics of the rider pedaling, it's very difficult to actually quantify it. So there's the potential for other product manufacturers to start embracing aerodynamics, and I think there's going to be a real increase in performance, stability, and safety within the product lineup in sports. One area where I'm finding it interesting is that aerodynamics within sport affects all levels. We know to a tenth of a second that could make a difference for an Olympic athlete to be on the podium or not even make the top 10. And so we started an investigation of where our technology or where real-world aerodynamic technology could involve other sports. We started realizing that a lot of investment has been done into speed skating, for example, within the suits and the whole area there. But it was very difficult because, again, you're dealing in a situation where they had to develop mannequins. The mannequins are used in the wind tunnel model. So this allows for that validation and verification moving along. Bobsled is another area where the technology can be implemented, where real world aerodynamics can come into play. There's been a ton of studies done around bobsled in these sports within the tunnel, but it starts to allow for development of new products and new positioning. We also know that alpine could be an excellent situation where the performance of these athletes can be incredibly enhanced. And the classic, which we know was recently done here, is the sub 2 hour record being met. And in that situation, they brought in all the components, including aerodynamics at a low speed, which is incredibly impressive. So really what I'm doing at this point, and one of the things I really want to get across, is what are the creative ideas where real-world aerodynamics can really start to come into play. And so some of the brainstorming sessions we have had is, what if we actually implemented a cellular connectivity within our system? Could it actually do impressive real-time data analysis and data capture that can increase an athlete's performance on a long-distance course situation, for example, like an Ironman scenario where the athlete originally is set up in a probably optimized position in a wind tunnel or with a fitter, but how does that athlete's performance change as he gets to that 100 kilometer, 150, 180 kilometer point, and how that can be optimized? Another area where we started thinking, what if this was capable? And we looked at things like, what's the potential if somebody had a wireless body motion analysis system that did not interfere with the rider, allowed him to just get out and train and ride, where performance directors or analysts could actually look at what's happening in a real world situation compared to a lab setting like a fitter studio. The other thing that we started kind of looking at within a non-invasive body motion analysis system is, could this be used from a proactive standpoint to prevent injury, but also recover injury recovery, but allow the athlete to get back to what they like to do, which is ride and race. So from that standpoint, is the potential there? So again, what I'm really trying to do is throw a lot of creative potential ideas out there for the viewers to kind of go and say, you know what, that has some interesting applications and implementation. Another area that we started dabbling in is multi-rider drafting analysis. So we saw the earlier study done with over 100 plus riders in a peloton. So in that situation, again, the test was very well done, but there were some exceptions that had to be taken into consideration. All riders were the exact same size, shape, and so forth. They were assumed in a perfect position within that peloton. We know that that situation would not exist in the real world. So how would that look in a peloton situation if we did a very large study where we actually did 50 or 100 riders using a real world system, as well as for development within TT situations? How can the riders, whether it's an outdoor or an indoor situation, how the riders could be optimized with their aero drag with a system that's integrated and they're communicating within there to grab data analysis. Another area where I think this is kind of an interesting and exciting area is to actually utilize a multi-sensor integration or metabolic system. So what's happening, we know right now with the real world aerodynamic systems they're developing, is they're capturing the external environment. They're capturing, temperature, humidity, elevation, and so forth. But if you started bringing in some of the other factors that have been very well tested, so for example, the internal elements of an athlete, so their VO2 max, and you start bringing into consideration things like their heart rate into the equation, sweat rate, and caloric burn. Is there a way where the technologies are coming together to actually determine when an athlete who traditionally works with a way of feel that they're at the below the red line in order to optimize their maximum performance but continue to perform? Is there a way where taking external environments which affect different athletes differently. Some perform great in heat, some don't, but bring their personal elements from their prior testing into a profile system that could actually determine when they need to keep on certain things, when they maybe need to pull back, or whether they have the opportunity to increase their performance because they are nowhere near hitting the wall. So again, it starts coming down to these what-if scenarios with the technology and how it can really be leveraged as a new infancy stage technology. So the real takeaway that I'm trying to get across in my brief presentation is to explain that this is an early stage of a technology, and right now, coming from the standpoint of a lot of the people present of being elite in their area of expertise, academic, manufacturing, high performance athletes, what can start happening with the information as it starts to be gleaned through the scenario here? Aerodynamics influence sports performance in all levels. And we also know that aerodynamics is unique to most people. So there's not, again, that silver bullet, one product that works for everybody. So could this lead to a helmet manufacturer looking at certain body types and actually develop or design helmets that say, this style of body geometry is best suited for this helmet. This one is for a different for a different style of person. So it's interesting that it can open up the opportunity to develop customized products where people can be more selective to optimize their overall performance. Manufacturers can build now better products for their customer and really start to look at that. And that leads to my earlier comment of taking and building a better product because they can now cycle back what they have on their current iteration and bring it back into their redesign that they're planning on a relaunch within the next 2, 3, 4 years, and they're ramping up for that stage. Experts can look at starting to define new metrics. Again, getting back to when heart rate first was the gold standard and for performance, and then the power meter and so forth. So what's really, I think, potentially is going to happen is there's going to be new metrics that are defined within the aerodynamics, the research and so forth to quantify better safety, stability, and performance overall on different products, whether it's within the sports area or other products that are related to everyday life. The integration. So there's the potential here for, we have several products that are on the market, and there seems to be no magic moment when it all gets integrated. So, you know, the heart rate with the power meter, with other factors, the tire pressure and sensors and so forth, is there the potential for an integration of these peripheral sensors to actually give a control system to really bring all that in. And the good example I talked about earlier was that metabolic system, where it starts bringing in peripheral sensors into a brain system. The possibilities, so another takeaway is the possibilities for additional custom aerodynamic solutions. So again, mentioning things like the socks in the wind tunnel that were talked about earlier, I believe Steve had talked about that, is in the wind tunnel, you know, how can that be dealt with? And again, that might be a custom solution. A rider who's a shorter stature with larger calves may not be able to optimize. And again, they talked about bicep and so forth. So that could be a situation where customization of fabrics, materials, and other products to create unique custom solutions for performance athletes. So at this point, I'd like to thank you for your time. Again, the idea was to get people to really start thinking, what are the opportunities in front with this type of new technology coming forward? So I'd like to thank you very much and open it up to any questions.
Fascinating about this customization you're talking about. So, and where is the challenge for manufacturers? Because manufacturers are in the mass production business, and you're now talking about, a customized solution, be it a helmet or, maybe a pair of socks or some overshoes or some cycling kit or other aerodynamic add-ons to the bike. Where's the line that we're going to cross between, mass production and customization?
Well, good question, Steve. We're already seeing that. I don't know if people are aware, but for example, you can actually order a custom Nike running shoe. So to your point is there's the two factors. You can order off the shelf products, or you could have one-off custom solutions. But to expand on that further is that maybe the example of a helmet manufacturer, they might realize when they do their extensive study that they identify 3 body types. So of those 3 body types for a helmet, they may determine that these 3 products fit best for a certain body type. And it's no different than maybe circling back around through the shoe. Buying a shoe that has a little larger toe box, or shoe manufacturers that give you the same style of shoe, but it has different gants within that shoe. So, and I also see the fact that there's going to be a lot of manufacturing coming forward, and we're starting to see that. There's bike manufacturers that are actually talking about having it where you actually send in your specific measurements, and the carbon fiber bike is actually built to your specific measurements. So, believe it or not, it is around the corner. There's a lot of companies either implementing it or about to, and so I do see that, and especially in clothing. There would be a great example where a person's trying to optimize the perfect fit, and it's something that's important to them. So a kit, for example, would be a great situation where an athlete, again, has a little longer reach and so forth, and he needs that. So I see it happening. It's already happening, and it already exists if you just slow down and kind of look at certain things like running shoes and some apparel.
You know what I find really interesting, Kelly, is a lot of this information, what you're talking about is started to leak out or flow quite readily out to the layperson, to, people out in the community, enthusiasts. So my example is we were watching the PTO championships at the Daytona Challenge triathlon last weekend. And you and I, we were talking about this in our prep session for today. And there was actually people critiquing Paula Findlay's position on the bike, the clothing she was wearing, the wheel choices she had made. Like, all this stuff was being critiqued on the fly in chat forums like the Slow Twitch forum, or sort of online on Twitter. It's amazing how this information gets out there and everyone sort of becomes an expert. Your thoughts?
Yeah, and good to that point, and that probably touches on the marginal gains, right? People are adding up and going, "Oh, here's a possibility." So again, there's a situation where Paula Findlay has a lot of resources. She has some great sponsors, and I'm sure there was great insight specific to what she needed as an athlete, and that'd be a case in point. We also don't know if she had any possible limitations with injuries and flexibilities where Bert had talked about just slamming down the stem in the early days. Well, the reality is we are not all flexible and dynamic in equal ways. So, to your point there, everybody seems to be an expert in an area where that's really subjective, and Chris would have a good laugh, and every aerodynamicist, where a person looks at a photo and says, "Oh, I can tell where that person's aerodynamic." So, to your point is it does. People are also interested about this. People are also looking at ways to make themselves faster, and they're analytical, and they're trying to glean information from experts to do that. And, Ironman's a great example of that. You've got a lot of people striving to make it to that event, or things like the challenge events. And so, they're looking for anything that can save them a few watts so that they can go longer, faster, and ride safer for stability.
Questions coming in from the attendees. Thank you to everyone who has put in questions. We've got a bunch of them, Kelly. First one coming up from John Bennett. Thank you, John, again for another question. John is asking, can the AeroLab testing be used for speed skating and skiing and those more sort of dynamic body sports as opposed to, on a bike where it's fixed, I'm guessing?
We've done some preliminaries, and to that comment, yes, we believe it can. Each one of those areas, for example, will have their unique challenges, right? Whether it's the speed skater being indoors. So, how do we figure the scenario out there for speed cadence, for example, or power? You need to create a power device. So, in those early days with the speed skating, we started thinking about, okay, can we utilize a pressure pad within a sole to convert that to the power output as part of the equation, because these are all the variables that are needed. And, things like bobsled, actually with bobsled or skeleton, we think it would actually be an easier implementation. And areas like alpine would be a great example. There's been a lot of people trying to resolve the issue of the GPS limitations within alpine. So to that question is, I believe there is ways to implement our real world technology that way, and even look at things like parallels. For example, CRR we know is a very important component within aerodynamics, because again, it's a loss of energy source. How does the ski chatter come into place? Is there a way to create a vibration sensor to look at that? So there are challenges that are specific to each of the sports, but I think the key component is aerodynamics is very important within that sport, and B, the majority of the challenge, the 80%, is dealt with. How do we bring in the missing variables in that? Because again, our philosophy with AeroLab has been, don't assume anything, and that comes into play. So we definitely have thought out a lot of those case studies, if they would be that.
Awesome. Question from Chris Bloomfield Brown. Thank you, Chris, for the question. It's a bit involved, Kelly. I'll try to sort through it. It relates to aero body position and core body temperature, I think is what Chris is getting, and how the two are sort of interrelated, and the trade-offs between, I'm guessing, being more aero, and if I'm to understand body cooling, it's based on evaporative cooling. So the less exposure to the air, the less cooling effect you would have. I think that's where Chris is going, with the question. Your thoughts on that?
And a great question, because that's exactly it. You've got an engine and it's running close to redline, and how are you cooling that system? So, to that point, which, kind of maybe teases out with that comment of the metabolic component, is again, you're dealing with an athlete and the individual. So we know some Ironman athletes are phenomenal, and some cyclists are phenomenal in colder climates, but when they get into higher humidity and so forth, so their body dynamics, their metabolics don't bode well for that environment. So, to that point, that's where an athlete would have to make their own decisions. And so again, kind of touching on equipment, where some athletes will opt to a less aero helmet because it has better venting, because they happen to be having a race day in an environment that has higher humidity and so forth, or heat, that they don't perform as well in. And so really it kind of feeds back to that athlete having their selection of equipment that's best suited for them. And, to that comment, a case in point is I handle high humidity. I've raced in Cozumel, Ironman, and so forth. I actually race with a aero helmet, and the venting isn't as important to me because I don't overheat easily, where I know that there's other athletes that do. So to that point, it really comes down to a key point of that athlete. And that may be a situation where they were earlier discussions were things like a skin suit with a long sleeve to a short sleeve. That athlete knows specifically. So that kind of feeds back again to that product specific needs as athletes start to look at those type of manufacturing limitations. or opportunities.
So that would be personal customization, if I'm to understand that correctly. And we certainly see that debate, with a lot of athletes, online on forums like the Slow Twitch forum or elsewhere, going into the Ironman World Championship, making the choice of helmet, because we know that, there's a massive range in ventilation that you would get, with a helmet. So athletes are making those individual choices based on their own needs and customizing their choices based on those needs. Is that what you're getting at that?
Yeah, that's exactly it. And, we've seen it, you see it in situations where, the cold weather, again, it's athlete specific, knowing his limitations. And, jokingly, we've seen it, Steve, at an Ironman race where the weather was so cold that the athletes actually did their cycling section in their wetsuits from the swim. So I'm not saying that's a good situation, but that's a situation where they realized that their equipment selection originally wasn't going to suit the environment they were in.
Question from Olav Boo. What would be required to enable this in practice for speed skating or alpine, enabling same level accuracy as aerometers for cyclists as an alternative to wind tunnel or velodrome testing without adding a lot of assumptions?
It really comes down to finding out what data points or what factors aren't there. So specifically talking in a correlation between what's available in cycling with the manufacturers of real world aerodynamics into speed skating. So one of the things we already know is that with using this type of technology, you need to know the power output of that rider. So you need the power meter. So for example, speed skating, you would need to somehow come up with a way to measure that athlete's power output that's specific to them. So, one of our original ideas was having a footbed that has a sensor in it that captures the force load. Another, so that would be one example. The other factor that happens with speed skating is we use a GPS system. Some systems use a wheel speed cadence sensor. So you need to have a tool to somehow measure their speed velocity. So they're just looking at a few things where instead of taking an assumption, how do you resolve that specific challenge, that specific sport? Running with that example of comparing it now to, say, bobsled. Bobsled in itself, you don't have a dynamic person. So that, again, takes that equation out. But there you're in the outdoors and you can use GPS. So there's factors within bobsled that can be addressed as well as speed skating, but they have their unique challenges. But each one is really just going down that checklist and going, okay, how are we going to address this missing variable so that you don't take assumptions?
The device, your device, where do you see that positioned? Is it something, a tool that would, the layperson, the average athlete would purchase, use, or is it for coaches, or is it for team, performance, directors? Is it, to be used in the lab? Where's the appropriate place for your device to be used?
Specific to AeroLab, because we've gone to an area where we want it to be the highest standard and bring value to the wind tunnel, a lot of our product, it is higher end. It is lab grade. It is automotive grade in regards to its GPS sensor. And so we wanted to focus on that. So for our product, for our product right now, it is more of somebody who understands the protocols, because we know that simply doing a test, you can make a mistake and it could ruin the whole test process. So ours right now is slated to the academics, the engineers, the manufacturers developing new product, the performance director, and the high performance coach. To that point, it's also a lot like Bert said when the first power meters came out. So that's why I do liken that comparable to power meters, is that when it first came out, what I have gleaned is that as a person as an engineer and an academic, they'll always say, okay, give me the data and I'm going to parse it and look at it how I want. Where a consumer at the bottom level is saying, okay, what's it telling me? So I think from that standpoint, it's a lot like the power meters right now. It's taken a lot of time to get there. People have become educated with articles and seeing the athletes use it and how they're using it at high performance, and they learn to adopt it. So for our technology right now, it really does need somebody who has understanding of the methodology, the protocols to do a proper test, as well to help the person understand that data. So it's not meant for some rider just to slap it on his bike, not know anything about anything, and go out and ride and say, hey, you know what, helmet A and helmet B are the same, or better or worse, that type of thing. So it does need for lack of a better word, a technician.
Right. And it was the analogy with the power meters and what Bert was talking about was perfect, because power meters were used in the lab, then they kind of creeped out, and top level athletes were using them, and it was kind of a bit of a secret, and then now everyone's using them. And then as we saw this week, our friends down the road from you, 4i, just outside of Calgary, they're making their power meters available as OEM standard product now on a whole bunch of bikes being offered by Canyon and Cervelo. So maybe that's 10-15 years down the road for a product like yours. Is that where it might eventually go? And that could be a possibility, especially at a high level. Again, I know I'm mentioning the Ironman and so forth at the time trial, but I do see that where that could be integrated as part of the frame. I think Argon 18 had done that in their earlier concept development. And it could be a tool that's either built into the frame system or some type of add-on where, again, it could be telling the athlete a lot of information where they're optimizing everything. And then I do see that at a very high level. And we could, for all it could be something where UCI starts using it at the time trial levels, at the pro levels. And then eventually I do see a trickle down like you're seeing with power meters, because you got to realize power meters have been around 20, 25 years now. And so, it's taken time for that technology to become easily digestible for the average consumer, that they can just walk into their local mom and pop bike shop and order their bike with a power meter. Is there a danger, Kelly, of too much data and just being overwhelmed, by the data here? I mean, I see this with a lot of athletes being, coached. Is there more obsessed with the data and the information than they are, with the actual training that they have to do? I mean, you've got to put the work in, to be ready, and then fine tune, with the data. Isn't that more? What needs to be done? Yeah,
I'd agree with you. And, kind of looking at it is a holistic strategy, right? Again, getting back to that athlete for his specific needs, and anybody who's using a coach or looking at it. And you're totally right. You've got the person who tries to buy speed. Well, you can only buy speed for so long. You need an engine, like Bert had used the example where, maybe he didn't have the engine, but he use the data correctly. And we all know that, if knowledge is no value unless you implement it and use it. And so, getting back to the earlier point of using real world aerodynamics, is that you kind of need an operator, somebody to guide somebody. Yes, they could be somebody who's really into the data, but a good guiding coach, a performance director, and so forth would say, okay, this is what it's telling me. This equipment, no matter how much you like that helmet, that one helmet over there, that's your go-to helmet, it's costing you 5-6 watts. So this is the only time it should be used, this type of thing. So it really comes down to empowering the data person and saying, and watering it down, saying, okay, here's the goods and the bads of certain things. And so that kind of getting to that point that's where I think early on an operator, whether our technology is used by a performance director or a fitter, that type of thing, a high level quality fitter. But you're totally right. People can get paralyzed with too much data.
Last call for questions from the floor. And there, just as I said, that one comes in. This is from Harm Ubens. I don't know if it's a question or a comment. I'll just read it out verbatim, Kelly. That would probably be easiest. The technology is about optimization. However, in his presentation, Chris talked about the small changes falling in the same region of accuracy. How far can you go in optimizing position and gear? Or are, for example, wind tunnels still needed for that final fine-tuning edge?
So I would actually flip that around. Is the wind tunnel gives a good guideline for developing, but if you're dealing with dynamics of an athlete moving and so forth, so, case in point, we have resolved discussions at a very high level, at Olympic level, where they could not get the athletes in a wind tunnel. So they were limited by the wind tunnel's capability within the scales and the jigs and so forth. And so we were able to definitively resolve a heated discussion over which booty was more aerodynamic for their Olympic athletes. And, case in point with that. So, in the real world, you actually have different elements. So the wind tunnel's excellent. It's a lab-controlled environment. But what happens is the real world is a lot like CFD. You have some assumptions, but you have some things where you're pretty confident it's going to happen within the wind tunnel. And that happens in the real world too. So if we run, for example, airflow, in the real world, we know that there's dynamic airflow, there's wind gusts, there's different layers at the lower levels and higher levels of turbulent airflow. So, to that point we can get very accurate, but we can also address challenges that can't be addressed in the wind tunnel. And reverse is the wind tunnel is excellent for a controlled lab situation where you can just step in, do a slight change, and step back out. So for development of iteration. So they both have value to each other at the end of the day, and you don't need to take, take anything from the real world environment and bring it back out. So it's almost like it's an evolutionary step. The product's developed, and then when you put it in its real case scenario where the athlete's actually performing dynamically, you see that it actually worked to how it was designed, or not work to how they thought it was going to be designed. And to maybe touch on this a little bit further, Steve, a good example is we also did a test with a top manufacturer and a pro athlete. And in the test, they were directly comparing the Garmin velodrome system with the real world system, and then the reports were handed independently. And what was really interesting within that test is the athlete itself, he did not have any experience within the velodrome, as he was a Ironman athlete. And what was really interesting about that was his total body dynamics had changed. So within the velodrome, he was very stiff and rigid because he was at high speeds that he wasn't used to in a closed environment like that. But also it's just the inherent nature for him to lift up his head in the corner. So he was, it was difficult to take him and put him in a velodrome when his natural instinct was to be out on the road. And so his body language changed, which affected his aerodynamic performance on what we were seeing in the velodrome with the Garmin system and what we were seeing in the real world when he was actually performing closest to his natural environment. So hopefully that answered the question a bit with the wind tunnel and bringing in the velodrome.
Two more quick questions before we move on, Kelly, to our next presenter, who we're really looking forward to hearing. Iago Alcalde is asking, when is the product going to be 100% available?
The product actually is available after this symposium. We are working with several pro tour teams. We're working with federations and so forth. So we're actually releasing a limited release here because of what's happened with delays. So originally the product was to be out in November with this select group, but it's actually available now.
Okay. And final question goes to NCCH head coach, the NCCH program operating out of Hamilton, Ontario for youth. Some of the top cyclists in Canada have come out of that program over the last couple of years. Coach Rick Lee is asking when you'll be rolling out testing centers in the provinces in Canada.
Rick, thank you very much for that question. Believe it or not, I think it must be a cruel irony because here we are, we live in probably, I'm going to say, the best ski environment in all the world here in Calgary and a ton of snow. Canada is really not our market. We're 99.9% export, but I know Rick is in Hamilton, and I know the mountain velodrome is out there, and AeroLab and its subsidiaries support Triathlon Ontario and a couple teams. So chances are what'll happen is we will be having something out in Eastern Canada, but also to that point, we'll be getting out to Eastern Canada to support the Canadian athletes as much as we can. Thanks
awesome.
for the question,
Thank
Rick.
Thank you for that question, Rick. And I don't think he was meaning to put you on the spot, Kelly. No, I mean, the Mattamy National Cycling Center is a bit of a hub for cycling in the country, as you well know. Yeah. So it wouldn't be a bad idea to have some availability via that wonderful facility. Virtual round of applause for Kelly Zwarych, the co-founder and the CEO for AeroLab Tech. I can hear them clapping.